allows producing values from a function while preserving its state, or while still executing, you can provide an output. I'll give you a simple example for reference for us to understand what is it and why it is used. Think about this. You have an iterable, and for each element of the iterable, you want to perform some operation. Let's say there are 4 iterables. For each element of the iterable, you want to perform an operation. And after performing an operation, you're going to take that iterable result of that particular operation, and perform something else on it. What happens in this case is, since you have a value such as A, and you want to perform operation on it, then operation on B, then C, then D, you have to create a function which will take all these elements, perform operations on them, give you the response. After you get the response, you then perform something else on top of them. This becomes complicated for 2 reasons. Think about this. Let's think about this. Let's say you have a list of file names. These file names are images, a.png, b and c and d. Your first step to do is convert them to from RGB, that is from color, to grayscale, that is black and white. Once you've converted them from color to black and white images, the same 4 images, you then take them up and perform some other operation. Other operation as in, let's say, an operation like identify the text within them or something like that. Now, here's the catch. If you convert all of them to grayscale and then send them to perform this operation, it will take time. Instead, what you can do is you can create a yield function, and you can send these elements of this list to the yield function or the generator function. This particular generator function will go through each element. After it performs conversion for the first element, it will return the value of it so that you can continue with first image and perform your operation on it, that is, perform character recognition on it. Meanwhile, it will then perform this for the second image. For that, you can perform your operation. Meanwhile, by the time it will perform it for the third image. Simultaneously, by the time it will perform the result for the calculate the result for the fourth image. So the purpose of this, or the way this particularly works, is it performs these operations for each image at a time and sends the response back before applying that function on the second image. This is where generator functions are useful. That is, they continue to execute the function, but they return the output of the previous value. That's why generator functions are used. These are often, again, some specific use cases, niche categories. This is not something you'll use on an everyday basis, granted. However, it's a very important function to have in your arsenal of the functions that you know when it comes down to Python. It's quite an amazing function to be very memory efficient when you respond with data. Yeah, speaking of memory efficiency, one more thing. Think about large scale data analysis. You have a list of 2000 documents. This is a very large list. Now, if this generator is supposed to return this entire list, instead of creating and returning this entire list, this generator can return one at a time the moment it is created. This will ensure that large data is not sent in memory at once, and it becomes memory efficient so that your memory is not too damaged, like it's not too much used where a very large data or content is sent at once. Again, just another reason why you can use yield. There are a lot of such real and practical purposes of it. And the purpose why I'm specifying all these four functions together is these are the kind of functions that you use when you work on large data, like when you work on top of PySpark specifically. Although they are a part of inbuilt Python functions, that is where you utilize their true potential and true power, just so that we know. Now, with this idea, let's go ahead and create a yield function for our reference. To understand this, I'm going to import another module called time. Time, have we worked on time before? I'm not sure if we have. Oh, yes, we have done this. All right. So for those who don't know, you can just press Control Shift and F, and it'll search whatever you want to search within all the files you have opened till now, or that is all the files in the current project. If you want to search for some function call or something, anything at all within all the functions throughout your file system, you can just use Control Shift F to search for it. All right, moving ahead, let's go on to the yield function and see how it works. Let's create a function called calculate square. Again, a pretty basic function we are looking at, completely understandable. And here's what we're going to do. We're going to call this function for a list. Let's say, all right, yeah, let's say calculate square until n. Let's assume this function. So given a number n, you have to calculate all the squares from 1 until n, for example. Let's just call calculate square until n of 10. Now, when you do this, you're going to receive n as 10 here, and you're going to calculate square of each number until 10. So for each number, let's start with 1. By default, let's start with 1. Let's assume num equals 1. If num less than equal to n, as long as number is less than equal to n, sorry, not if, we have to use a loop while, right? Because we keep increasing number one at a time. We calculate square of the number. Square of the number will be num times num. And we have to store that result in a list, because so far what we know is this is the only way for us to calculate it. Let's take result as an empty list. We calculate squares of each and every number starting from 1, as long as the value num, which is initially 1, is less than equal to num. We calculate the square of it, add it to result, and then we increase num by 1. That's it. Once we do this, once this entire operation is done, we return result. So whatever is the result that we store, that we can print here. So when you run this, you get to see result is the square of all the numbers. A pretty simple function, right? So we have a function that will take a number, let's say 10. So for each number from 1 until we reach 10, we keep increasing it one at a time. We calculate the square of it, we store it in the result. The moment it becomes 11, it's greater than n, because less than or equal to is the condition. Even when it's equal, we continue ahead. The moment it becomes greater than n, we stop the loop and we return the result. Now here's the problem. It's returning the entire list. This is fine if it's a smaller list, but over time, let's assume when the list is very, very large, then um, it becomes very difficult for us to figure out how to perform this. It becomes very difficult for us to understand how to work around and perform these operations. So it becomes also difficult to return such a large amount of data within RAM, which takes more time and more effort, and more free RAM should be available to do that. A way to resolve this, on the other hand, is as follows. This is what we'll do. Instead of using this while loop and returning this, here's what I'm going to do. I'm going to ignore return result. Instead, I'm going to write yield num cross num. So yield is a generator statement. This will return the value and continue to execute the function. That's what it does. So when num is 1, it's going to return 1 times 1, which is 1. After returning it, it'll continue the function. Num becomes 2, it's less than 10. Again, it goes ahead, it's going to return 2 times 2, which is 4, and then continue ahead. This is basically what it does. A very simple and straightforward operation. Now, here's the logic. Here's the catch with this. Your result will not be a single result. Think about this. It's going to return 1, then it's going to return 4, then it's going to return 9, then it's going to return 16, and so on. It's going to keep returning one value at a time. Since it keeps returning one value at a time, it returns it as an iterator. Since it returns it as an iterator, we need to iterate through the result. So let's call this as generator response. And since it's an iterator, here's what you need to do. For response in generator response, for each individual response out of it, you can print the response. There we go. So pretty simple and straightforward operation. We're going to start with 1. We're going to keep going ahead until we reach n. Every time we calculate n cross n, we return it, and then we continue ahead. And each value that is returned is available as a response, and you can perform the next operation on top of it. So let's just remember, it returns a generator response, that is an iterator. We can iterate through each response and perform further operation on it. That is the whole idea of how it works. That's pretty much it. Now, moving ahead from here, let's go on to the next case. Let's go on to the next condition and category. Let's run this first. When you run this, you get to see the output is like this, but we still don't get to know that we are reading or we are getting back one response at a time, right? That's a difficult thing. How do I figure out we are getting one response at a time? There's a simple way to figure it out. After yield, after each yield, I'm going to use time.sleep of 1, indicating, or let's use 2, time.sleep of 2, indicating that after returning each response, before continuing the next statement, I will wait for 2 seconds. This is to simulate a real world operation where some application might need to wait. Think about this. When you're converting a large image from color to black and white, it might take a few milliseconds to do that or a few seconds to do that. Since we are not performing such a heavy operation, we are simulating the thought of running such a heavy application by using time.sleep. That's basically all that we are doing. So let's run this. And you can see the output here. So it's going to keep executing. Remember, the function is not done. The function is still executing. But for each execution, each step of the function, it's going to return the value, which you can do something else with while it gets to run for the next step. This is map, filter, reduce, and yield functions. So if there are any questions so far till here, I would request you to please let me know, please ask. If this seems easy enough and understandable enough so far, we can move ahead right away. So please take a few seconds if required. Any queries that you might have, um, please feel free to ask. Right, so I presume no queries so far, which means we can go ahead. That's awesome. Let's go ahead in that case. Now, moving ahead from here, we have a couple of other inbuilt functions which we haven't looked into, which we haven't completely worked in. So, yeah, let's take a look at one such function. Let me just cross-check if we have already done this in our data structures loops, or any functions where we have removed any elements within lists. Okay, I don't think we have done that. Okay, so it's quite important that we do this. It's quite important that we try this out and run this. So let's give a check on it and see how this works. Now, the whole idea of what we're about to just take a look at is how to delete some elements in the list. I think, again, I'm just a little confused. I believe we have done this, if I'm not wrong, in some file where I somehow remember us deleting elements by using range function somewhere. So if any of you are able to recall that we were able to look at deleting elements from a list, please feel free to let me know, because I am unable to recall or find it here for some reason. So I'm just gonna try this out very quickly to work on it in a very quick fashion. All right, let's delete elements or modify elements in a list. Now, whenever you want to modify elements in a list, please don't ever use for I in list I dot or I equals something else. What ends up happening here is that I will not be I is a temporary variable. It's not a part of the list. It can't be modified. Even if you modify I, it does not affect the list in any way. So rather take range of 0, comma len of list. I think I have done this in one of the previous sessions, though I'm unable to recall. And instead modify elements in such a way that you modify it in the following manner. That is list of I is equal to whatever modification it might be. I believe we have done this, so I'm just going to ignore this and skip this across. Right, so let's move ahead to the next part of this. Prior to moving ahead, please await. I'll just be on mute for a few seconds. Right, again, apologies for the slight delay. I Would not expect to have delays often, so please bear with that for these very minor delays of a few seconds. Anyway, moving ahead from this, let's go on to the next part of this. Right. This pretty much helps us know most of the basic things that are part of Python. So congratulations to us. We have learned a lot of basic things that you need to know in Python already. Now we can move on to a few advanced things, a few um, advanced level operations for us to work upon and solve upon. And let's begin. Um, Also, just for our reference, just so we know what is it that we're going to be performing up next, we have a few other inbuilt modules in Python that we need to know. Things like let's say the Python modules of regular expressions or working with date, time, and so on. We have already worked on file system and so on. So all these things. So a date, time, and some data handling functions and so on. So there are a few things that we will look at, the few things that we will um, try to look into, try to work around. Let's start doing all of that. But prior to that, there are two simple things that we're going to learn. One is called argparse and the other is called logging. Quite important things. Let's start with this. Let's create one more file. Let's call this as 10 argparse.py. Right. Now here's the thing. Think about this. Not every scenario occurs where a user will execute a program and then enter an input while the program is being executed. You might want to execute a program with some options at the beginning or at the runtime of the program to make sure that entire program running is automated. This is a very common theme that we see constantly when we look at Python modules. I'll give you one simple example when we look at this. Now, to show this example, I'll just go to this website, github.com, and within GitHub, I'm just going to go for, where are we? Let's scroll down. Okay, they have changed this. So I'll rather go for GitHub repos. There we go. Um, so yeah, you can access a lot of repositories that are available in GitHub. Let's take a look at GitHub Ice Cream, for instance. Whatever ice cream we just utilized, it's done by some people and they have released this by themselves. You can use it as a function. However, not every single module that you use is intended to be used in this order. Not every single module you use is intended to be used in this way. I'll give you a simple example. There are some Python speech recognition modules where you don't have to open the Python file and it'll give you an input prompt like enter the file location so that I can read it and convert it into text, and you type the file location. It doesn't work like that. Instead, for that speech recognition Python code, you just call speech.py or whatever that file name is and use a flag with double hyphen ahead of it and specify where the input file is available. Input file could be, let's say, a.wav file. This is the WAV file that you're reading, for example, for instance. This is how you can specifically read, let's say, a value or read, let's say, an element or a file name or whatever it could be before you run the program. You don't have to read it with input command whatsoever. You can pass it as an argument while running the Python file. This is exactly what we're looking to do. This is exactly what we are looking to learn. And this is something you will see a lot when you start looking into various applications across the web. and various, let's say, repositories that you might see. I'll just show one or two repositories that might use it. I believe we have, again, I'm just searching some random ones to show you this so that I can provide at least one or two examples of this that can show you how these are often done. So many people who create their own Python packages, Python modules, yeah, there you go. The moment we open up one good, let's say, repository, you get to see this. This is how it works. You can run it using command line in the following way. You can see here, double hyphen languages. That is, if you want to recognize the text from a particular language, you can use double hyphen languages followed by language names, or um, any specific features like this if you want to output it to a file or whatever it could be. So there are these specific options you can use when you run your Python file, and this will make sure that you don't have to enter execution of Python file and type something. You can let it be an entire command, and this command can be executed to automate the whole process. So you don't have to perform the whole operation. That is what I wanted to point out. That is why I wanted to show you one or two examples of these so you can get to know and figure out that a lot of developers prefer to create their applications in this way so that those who will execute these applications, it becomes easy for them without even entering their application, they can do that. I'm not able to figure it out if they have specified it here, the running. It's fine if they haven't. It's yeah, at least we saw one example which is good enough, like how we can specify languages for, and if you need to translate prior to a language, you can do that as well specifically. So these are called flags and arguments, and we're going to create our own application, a very basic application which can have its own flags or arguments to begin with. Right, so let's start with this. Our application is pretty simple. It's supposed to perform the following. Given my username, greet me with a hello message, something like this. So we're going to provide our username as a parameter, and we're going to ask it to greet us with a hello message. And the username will be provided as an argument before we run the program, not as an input function response while, or not an input function while running the program. That's the whole purpose. So let's try this out. Now, to perform this, you need to import this module called argparse. This is an inbuilt module that's available within Python, and we're going to utilize this. So the purpose of argparse is to make sure that it creates an argument parser that you can use for your program. Now, I'll walk you through each and every step that I'm going to make in this code. It's barely going to be 10 to 12 lines of code. That's it. Or maybe 4 or 5 lines of code. And I'm just going to walk you through the whole process. The first thing here is create an object of argument parser. So within argparse, you have something called an argument parser. We're going to need to create an object of that if we want to perform something. So let's first do that. I'm going to take argparse dot argument parser, and I'm going to create an object of it, and we'll call it as parser. Done. Now, here's the thing. When you create an object of argument parser, you see all of these have default values. There's no compulsory entry that you have to do within anything. all are default values. Every one of them has default value. So let's not enter anything. We'll figure out what we should enter something later on. Let's figure out how to beautify it and make it better later on. Now, once it is done, let's add a few arguments. Now, there are two kinds of arguments that you can add. There are positional and optional arguments. Idea of a positional argument is pretty much that it is compulsory. And optional, as we know, it is completely up to the user to use it or not. Now, let's add a couple of arguments and let's create them. So we're going to create two arguments. We're going to create parser dot add argument. First argument, we're going to call it name. And let's take parser dot. We'll add another argument. So add argument. Let's call it, okay, let's make sure it greets in two ways.